So welcome to Spring Security from 0 to Spring Security 4.0. My name is Rob Winch, and I'm the project lead. Today's agenda, we're going to start off with some introductions, and then we're going to give you kind of a hello security example. And then we're going to dive into some customizations, and then we're going to go into some of the new features found in Spring Security 4.0. 4.0 hasn't hit GA yet. For those that are wondering, it's expected in Q4 this year. So the stuff that we're talking about has not been released in a GA release, but most of it has been released in at least milestone form. And then throughout this talk, we're also going to do some white hat hacking. So we're going to kind of put on our white hat and try to figure out where some vulnerabilities are and how we can protect against them. Talk about various types of attacks in some detail, and see how Spring Security protects us from those types of attacks. So a little bit about myself. I'm Rob Winch, project lead for Spring Security. I lead the Spring LDAP project and have a few side projects that few of you have heard of, but I will be giving a talk on Spring Test HTML unit, just a little plug, tomorrow at 4:30. If you do web application testing, and you want to, particularly with HTML, and you want to learn how to not have to start up a server and still be able to run tests even with JavaScript, come to my talk. It will be pretty nice, hopefully. And that's enough plugging myself. Let's talk about what we're here to discuss in detail. So Spring Security, what is Spring Security? Spring Security provides comprehensive authentication and authorization support. What do I mean by authentication and authorization? Authentication is the who. Who's trying to access a particular resource? And you identify the who in a number of different ways. The most common way that you guys are familiar with is probably username and password. Type in a username password, and then if it matches, then you're in. And you might store that username password in a number of data stores, like in memory if you need to get up and running and show your boss something really quick. Or you might want to do something more practical for a real-world example, like a database or LDAP. Spring Security will support all of these out of the box. But username password is not the only way to do authentication. So for example, you might use X509 certificates. You might do single sign-on mechanisms like OAuth, OpenID, SAML, CAS. All of these are also supported out of the box by Spring Security. There's plenty of other authentication mechanisms, so we won't go over all of those, but just know there's a lot of them out there. And if you can't do it out of the box, it's very easy to customize. And we'll talk about some customization later on in the presentation. Once you've identified the who, you want to identify, are they allowed to access that resource? So given I know who's trying to access a resource, are they allowed to access it? And that's where authorization comes into play. And it's important to keep these two concepts separate, because if we change the way we're authenticating because there's this new whiz-bang authentication system, then you don't want to change all your authorization logic. And what's more is you might want to authenticate in multiple different ways. Maybe you have a single sign-on mechanism, but you also have a local authentication system. So it's very important to keep those decoupled, and Spring Security helps you do that very easily. What's more is authorization should be done in layers. So what do I mean by layers? Well, a lot of times in a web application, you want to inspect the HTTP request, and based upon that HTTP request, do some sort of authorization logic. For example, if the URL started with /admin, you might only allow admin users to access it. If the URL started with /public, then maybe everyone can access it. But what happens if someone bypasses this first level of security? You might say, well, they can't get past it, but they will get past it. People will find ways to exploit things, and there's no real way around protecting yourself perfectly. So you want to have multiple layers. So if they get past one layer, you can catch them. And so you can very easily add method level security with Spring Security too. So all you do is add annotation to your method, and you could say, all right, if you want to invoke this method, you must be an admin user. Or you might do something more advanced, saying, given the arguments to this method and the current user, make some conditional decision. And if it passes, then allow access. And you can also inspect the return result to see if they can view the results of that method as well. So there's a lot of nice things with Spring Security and authorization. We're going to talk about a little bit of the deficiencies found in Spring Security 3.2 and prior in its authorization model, and how we're working to improve those by providing Spring data integration with Spring Security 4.0 and Spring Data Evans release and forward. So there's also protection against common attacks. Who here has heard of session fixation attacks? Good show of hands. So even if you haven't heard of session fixation, Spring Security is going to protect you from that. Session fixation is essentially a malicious user will establish a session ID, and then they'll trick a victim into using that session ID to authenticate. And once they've authenticated, then they now can impersonate the victim. And how would they get them to use that session ID? Well, you could include it in a URL and say, hey, don't forget to change your password, it's about to expire, or something like that. There's lots of social engineering techniques where you could include the session ID in the URL and then trick a user into authenticating. So then, how do you protect against it? Well, it's really easy. You make sure that you know about the attack first. Once you know about it, you can just invalidate the session as soon as they authenticate, and then create a new session. So the malicious user now has a session handle to a session that's no longer valid. And Spring Security does this for you out of the box. You didn't even need to know this attack existed. You are already taken care of, unless you happen to disable it. But it's on by default. And there's other attacks that it enables protection for by default that we'll go over in more detail and kind of demo how they work. So the other thing that we have is we also have servlet API integration. Who here likes standards? Anyone like standards? I like standards too. Standards are good. So if you need to access the current user's information, you can get it off the HTTP servlet request. So there's a method to get the current user principal. Or you can actually determine if a user is in a particular role. You can also do things in the newer servlet specs. You can pass in a username and a password and authenticate the user just by passing it into the HTTP servlet request. Spring Security 3.2 added support for this and a logout method. There's a number of other new methods on there. And one of them actually is allowing you to change the session ID programmatically. So previously, Spring Security had to invalidate the session, copy all of the attributes over, and then create a new session. This could be kind of costly in a clustered environment where things maybe have to be replicated. So there's some optimizations in the newer servlets specification where we can just invoke that ID, and then it'd just have to update the identifier. We also provide optional Spring MVC integration. We'll get into that more later, but if you're using Spring Security, or you want to use Spring Security, you don't have to use Spring MVC. Of course, you want to use Spring MVC because it's the best framework out there, but you don't have to use it. And I briefly mentioned Spring Data Integration. We'll go over that in more detail later, but that's one of the exciting new features found in Spring Security 4. And then we're also going to talk about WebSocket security later on. OK, so now we've kind of gone over the high-level pie-in-the-sky view of what Spring Security is. Let's take a look at a very basic demo application. And we'll see how to apply Spring Security to that demo application. All right, so here's my basic application. If I request any of the URLs, it sends me to a login page. And you can see that it's very well done UI-wise. I spent years on this UI, copying and pasting Twitter Bootstrap. But the point here is it's a simple application, but we're going to learn the security concepts. So even the functionality is very basic. I can compose a new message, and I'll send it to Luke. Luke is the prior lead to Spring Security. And so then I created the message successfully, and then if I logged in as Luke over here, I would see it. Luke could also decide that he wants to do the details, or maybe he's just bored with that message and he wants to delete it. We also have instant messaging. So we can use WebSockets. So So what we can do here is, it appears that my UI, as fancy as it is, doesn't display very well at this resolution. So we'll just manually navigate. And what we can do is we can actually chat with Rob and Luke. And it's nothing really fancy here. and so we can do some chatting over here too. So you have persisted messages in the database that we're viewing in the inbox, and then we can also do instant messages that are happening over a WebSocket connection. And we're going to discuss in further detail how to secure that now, actually. So we went over hello, pie in the sky, abstract view of what Spring Security is, but now let's talk about how to code with Spring Security in a Hello World application. And even if you're advanced, it's best to kind of do this in incremental steps because it makes it easier for you to troubleshoot. Security is hard enough on its own, let alone when you're trying to combine it with a framework and your personal application. So it's very good to start with the Hello World application, even on something, even for the experienced users. I mean, that's actually how I start as well. So if you're brand new to Spring Security, the heart of the web application security is actually a filter. And the filter can intercept requests, and it can make access control decisions, send you to a login page, validate username and password, or it can totally ignore the request depending on what the request looks like. It's very AOP for the web. And the way you set that up is you create a delegating filter proxy. And the name of this filter is important. It's Spring Security Filter Chain. And the reason why that's important is because delegating filter proxy doesn't do any real work. All it does is it looks up a bean, a Spring bean, by the name of the filter name. So it's looking for Spring Security Filter Chain. And all the stuff that Spring Security provides to help you configure will be creating a bean by the name of Spring Security Filter Chain that implements filter. Delegating filter proxy will delegate all its work to it. So when you invoke do filter on delegating filter proxy, all it does is say, give me the bean by the name of Spring Security Filter Chain, cast it to a filter, and invoke do filter. So that means that we also need to create a bean by the name of Spring Security Filter Chain that implements filter. So we'll see how to do that shortly. And then you map it to every URL. Even if you don't want the URL secured, you map it to that URL. You can ignore certain URLs within your Spring bean definition. And we'll talk about that later. So if you're in the newer world and you don't like XML, and your servlet container supports it, you can replace the web XML with this bit of configuration. And in most cases, this is all you actually need. You don't need to do anything else. But there are some methods and constructor arguments that you can override, and that'll allow you to customize things. But for our application, this is actually all we needed. And actually, if you're in Spring Boot, who here is using Spring Boot? Anyone? Anyone excited about Spring Boot at least? Everyone should be raising their hands. Otherwise, get out. No, I'm just kidding. But in all seriousness, you really should be excited about Spring Boot. But if you're using Spring Boot, you didn't even need the web XML or the previous class that we looked at. It takes care of that for you, both of those for you. So now we need to determine how to create our Spring Security filter chain. So we're going to use Java config instead of XML-based configuration. And the heart of it is just the configuration annotation. This is how Spring knows that this is going to specify what my config looks like. And so once it does that, we need to also tell it that it's a web application and we want security. So we have enable web MVC security. Now, the MVC in there is because we're using Spring MVC in the rest of our application. If you're using Spring Security with some other framework, then you would just say enable web security. A lot of people say, well, why can't you detect that based upon class path changes? Do a Google on the Jira, and you'll see why we weren't able to do that. We figured that out in a release candidate that older versions of Spring couldn't do it, but hopefully we'll be able to do that. We're looking into making it so that it can detect it automatically for us in Spring Security 4.0. But the important thing here is that we're extending Web Security Configure Adapter. And it's providing a lot of reasonable defaults for us. The class name is irrelevant, but you want to make it make sense so that you can find it and read your code, but you don't care what that is. Now, the one piece of config that it won't default is your authentication information. And why is that? Well, the reason why is because we don't want you to forget to change the defaults. That's one of the most common issues in production environments. And you forget to change the default username and password, and then someone gets in. So we require you to do that, but this is all you have to do, is you provide a method that looks like this. And now you have an admin user and a regular user. And you'll notice, too, that the roles method there, if you're using XML config back in the day, you do role underscore a lot of times with the XML config. If you use the roles method, you don't have to do role underscore. So it's making that more concise for you. And at this point, if you logged into your application or started up your application, clicked on any of the links, you would get this beautiful login screen, which I spent even longer on, as you could tell. And the thing that's nice about it is, you say, oh, this is pretty hideous, but I didn't have to do anything to create this login screen. Well, I take that back. Technically, I did because I'm writing Spring Security, but if you guys were using it, you would not have to code anything to get this login screen. So it's going to help you get up and running quickly. We'll see how you can customize it shortly, but there's no need to do anything. So it's just making you that much more productive. And once you enter a valid username and password, then you want to be able to conditionally display things based upon your user information. And you might want to display the current username. So in this screenshot, the user's name is user. and so how do you do that? It becomes the question. So here I'm using Timeleaf. Who here has used Timeleaf before? Anyone? All right, Timeleaf. It doesn't really matter what UI technology you decide to use, because here the important thing is you can access the HTTP servlet requests. That's where we're getting the information from. And there's other ways to get this information, but this is kind of illustrating the integration with a servlet API. So if you look at the top there, we have HTTP servlet request.user principal. And all that is doing is it's getting the servlet request and invoking the method getUserPrincipal, which is on that method. And that can be null, or it can return a principal, which is your current user. And so then on the principal, there's a name. So that'll return the username. So current user in this instance, current user is going to be null or the username. Now all we have to do is say if the user is not null, we will display a logout link and the current user's information. And some people might say, well, I'm not really following. What's that sample user in there? That's just a Timeleaf thing. Timeleaf allows you to view the template not on the server side. And so you can have mocked up visuals in your actual code. So if you're viewing it in the browser, like just mocking up your UI, you have sample user. But when you actually run the code on the server, text there, current user, it's going to replace sample user with the current user. So that's what it looks like on the server side. All right, so now we're going to make that make that login form look a little nicer. And to do that, the first step we want to do is we need to provide some additional configuration, but we want to understand what our configuration looks like right now. So we can look at the parent class of Web Security Configure Adapter, which you see displayed right here. And this gives you a good idea of where to start. So this is basically saying that I want authorization on any request and require the user to be authenticated, and I want to support form-based login, and I want to support HTTP basic. So hopefully that's pretty clear cut. But how do we make it understand what form-based login is? And more importantly to those that are migrating to Java configuration is how does it relate to the XML configuration? Well, if you look at it, it should look fairly familiar if you're using XML config. The HTTP variable actually corresponds to the HTTP XML element. Use expressions is done by default because it's a much more powerful way of doing things, and Java config is new, so we can turn that on by default. And then we authorize request is similar to intercept URL, except it's just authorization. It doesn't do anything with channel-based security. Channel security is broken up to make that a little easier. If you're not familiar with that, don't worry about it, but know that you can state any number of patterns and access attributes on the authorized request. So here it's saying any request. That's similar to pattern / star star. And access equals authenticated is replaced by just authenticated. So we can even make it a little more concise with the Java config, and we get compile time checking and auto-completion. So that's kind of nice. The other thing I'll point out is the ands are similar to closing XML elements. So if you look form login and, it's similar to form login closing the XML element. If we needed to customize it, like we're about to do, we would place any of those attributes after form login and do an and. And you also notice my convention with the indentation. It's not important to indent this way. It's more important to do it how you can read it. But the way that I can read it very readily and how it was kind of designed was kind of similar to the XML. So if I'm customizing form login, I indent a little bit, and all of that applies to form login. And then as soon as I do and, I return my indentation back. Again, it's not important, but it's a nice tip if you're trying to figure out where my crazy indentation is coming from in these examples. So beforehand, we talked about Spring Security is rendering a login form for us. So how do we customize it? Well, we didn't specify a login page. So Spring Security said, no problem, I'll do it for you. So if we want our own login page, all we have to do is specify it. Now, if you aren't authenticated and you need to be, Spring Security is going to do a redirect to /login. And that means we're in charge of rendering a login page when that URL is requested. What's more is we said that any request must be authenticated. So if it does a redirect to /login and we aren't authenticated, then it's going to request login and then say you're not authenticated, and then it's going to do a redirect again, and it's going to infinite redirect loop. So we add this permit all underneath the form login. It's just a shortcut because in most cases we can guess what login page looks like. But we don't want to guess in Spring Security. We want you to have to be explicit. So here you can say permit all, and if your URL is /login, then it's going to grant access to it. But you know, there's things that it might not take into account, like content type or something like that, that might make it need to be secured. And so we don't want to make any assumptions, so you must explicitly state permit all. And we do the same thing for the logout at the bottom. And our login page is also going to have some resources, CSS, JavaScript, images, and we want to be able to access those. So what we do is we add this ant matchers. So ant matchers is, if you're not familiar with ant patterns, ant is just a way of expressing things, kind of similar to bash, but not exactly. But this is basically stating if it starts with resources, then I want to grant access to all of those resources, to any user. And the thing to point out here, too, is the order matters. Order is very important. Because if I had any request first, it would hit that and it'd say, well, it's any request. You must be authenticated. And we'd never get to ant matchers at all. So it's important to be more specific to least specific. And it's always good to have a catch-all at the very end. So in case you miss something, that it gets picked up. So at this point, we're still in charge of rendering our login page. And again, I'm using Timeleaf, but it doesn't matter. It doesn't matter at all what UI technology you use. The important part is, what does your HTTP request look like at the end of the day? So I'm going to highlight the important parts of the HTTP request here. And this is basically what it needs to be: a post to login. And the username and password HTTP parameters should have the username and password. And at that point, Spring Security can use our in-memory config, do the username password comparison. If it fails, it'll send you back to an error page. Otherwise, it'll continue on to the originally requested page. And you might say, well, where is that coming from? Well, it's actually coming from our config. So here we said a /login is our login page. So that's a get to login. A post to login by default, based upon this config, will validate those. Now you can customize that. If you wanted to have a different URL to authenticate, you could do that. But we aren't doing it because it's easier. Same thing if you want to customize the username, password parameter, you could customize those as well. And at this point, we have our custom login page. And now our application is looking more consistent and giving a more realistic look and feel. And so now the issue that we have is we're still doing in-memory authentication. and we want to do something more realistic. So how do we do that? And why do we want to do custom authentication, and why don't we want to just integrate with Spring Security and not have to write any code? Because less code is better, right? Well, there's a number of reasons why you want to do custom authentication in most situations. And the reason is Spring Security is trying to be as concise about its task as possible. It wants to identify, are you authenticated, and are you authorized? But your application is more about authentication and authorization. You have some domain idea of what a user is supposed to look like. So for example, you might have bank accounts attached to a user. You might have a home address attached to a user. There's all sorts of pieces of information that your specific application is most likely going to have. It might be as simple as a first and last name. But Spring Security can't make those decisions for you because you'd have a really bloated object and everyone would be mad about how many attributes were on that object. So it tries to be as concise as possible, but you still need access to those attributes. So that's why you kind of need the custom authentication. And here's how you can kind of blend your user domain object with Spring Security's authorization and authentication. So the first step is, if you're doing username password-based authentication, you implement this interface, user detail service. And it has one method, load the user by username. So you find the user, give it a username, give me some information about the user, and that information is what Spring Security needs to know. So that's pretty easy. What is that information that Spring Security needs to know? Well, it needs to know the authorities. So that's basically saying, is it an admin user, or is it a regular user? Is it a DBA? Those sort of things. So you can do authorization. And after that, it also needs to know username and password. So when you submit that username and password on your form, how does it validate that it is a valid user? So it'll use the username and password return. And then we have some expired enabled attributes. It uses these because it provides some additional features. If those flags are flipped, it can do some special things for you. If you aren't worried about those, you can always just hard code them to say, just treat it as always enabled. So here's our user model. Our user model is pretty simple. It has an ID on it. And you notice Spring Security's user model doesn't even have an ID on it. So if you're relating any data, it's always best to relate to a foreign key, not a username. You could use a username as a foreign key, but the issue is you get someone that signs up, and maybe you have Jane Doe sign up, and Jane Doe gets married to John Smith, and her name now is Jane Smith, and now she wants to change her email address. Well, all your foreign keys are jacked up. You can't do that very readily. So if you do it to identifier that's not interacted with by the user, not dependent on your authentication system, you can easily swap that out. And what's more is you can add things like single sign-on, which might not even have an email address in the single sign-on mechanisms. So it's always best to link to something that the user's not interacting with. Then we have our properties, first name, last name, email, and password. So how do we get this to work with Spring Security? Well, what we can do is we can create a user details, and we'll call it custom user details. It doesn't matter what it is. But it extends user, so it is a user, and it is a user details. So we can treat it just like a user. We have no idea that it's a user details. And we can treat it, Spring Security can treat it like a user details and not worry about all those extra properties. And so we don't really care about authorities in this application because it's very primitive. But if you did, you could look those up in your database, LDAP, wherever you're getting them from. Here, we're just going to hard code role user. And we don't have a username, but we have an email address that we're using for authentication right now. So we just map email address to it. And password's already there because we had a password attribute. That's in our superclass. And the enabled attributes we're just hard coding as true because we don't care about those either. But if we needed them, they're there. So now we just need to implement a user detail service. And that's pretty easy. We use our existing repository, user repository, to look that up. Here I'm using Spring Data. Has anyone used Spring Data? Hopefully everyone. Everyone excited about Spring Data? Don't make me kick you out. OK, no, Spring Data is super awesome too, and you should be excited about it. But here we're using Spring Data. If you weren't using Spring Data by chance, you just use your existing APIs, look up the user, and then if it's null, then you throw a username not found exception. That's the Javadoc onload user method. And then otherwise we return custom user details. So again, custom user details, it implements user details. So that works for the return signature of this method. But it is also a user object. And we'll come back to that in just a moment. All right, so how do I configure this? Earlier we had that in-memory configuration. All we need to do is delete that and replace it with this. So now we're auto-wiring our user details service that we created and specifying that in the authentication. So what good did all of this do me? We did all this work. What am I gaining out of it? Earlier I said we need to access these custom attributes. Well, what if I wanted to be able to access the first name? Right now we're displaying the username, but what if I wanted to do the first name of the user as opposed to the username, because I wanted to be more personable or something like that? So here we have, again, reviewing this, HTTP servlet request. We get our user principal, but that user principal also is an authentication. Authentication extends principal. So that's a Spring Security specific class. And that authentication has a get principal method. So now I can get the principal off of it. And that principal object is typically a user details. So that's the method signature that we saw earlier. But it's actually the same thing that we returned in our user detail service. So it's actually custom user details. Hopefully you see where we're going with this. Now, we can actually, the current user is our user object. And it has a attribute of first name. So now we can welcome our user appropriately. Now that was a little bit, I was demonstrating that to illustrate, again, the HTTP servlet request integration. You probably wouldn't even want to be tied to HTTP servlet request in your view. Your view could probably populate these values in the controller method. And we'll see how to do that in Spring MVC momentarily. But you probably wouldn't do it this exact way. It just helps illustrate where this information is coming from. So by a little bit, I mean right now. This is another way you could access that exact same information. And hopefully there's some alarms going on in your head right now. So the first thing is we're getting the security context from the security context holder. Security context holder is actually the way you access the current user. So if there's a value in the security context holder, Spring Security says this is an authenticated user, this is the information I use for authorization. So if you're doing any sort of custom authentication and there's not a way to do it, if you just populate the security context holder after you do your own validation of the user, then you will be authenticated with it. And this is a good way to do like sign up. If you're signing up for a new user, you can just populate the security context holder after they create a new account, and you're automatically authenticated. But some of the bells that should be going off and alarms is we have Spring Security specific classes in here. There's a lot of code here, is another thing, just to get the current user. There's a cast going on. There's null checks. So this is not ideal by any means. So let's see how we can clean this up a little bit. One of the things that you've been able to do for quite some time is you could just say resolve the authentication object for me directly. And why does that work? Well, it works because Spring MVC will automatically resolve anything that implements principal or extends principal using the HTTP servlet request. So we already said the HTTP servlet request is our authentication object, so this will work just fine. But again, this is still not ideal because we have a Spring Security specific class, and we have null checks and casts. So how can we improve on that? Spring Security 3.2 introduced authentication principal annotation. And this annotation is pretty much what you would expect after we've done this big buildup. It is the principal off the authentication object, which in our case is a user. So now there's no null checks, no casting of our class, and we have our exact user object. And if we remove Spring Security, we'd only have this annotation. But that's still not good enough because while I'm hoping you stick with Spring Security, you shouldn't have Spring Security all over your code base. It should be very centralized in classes that you're actually implementing for hooks to Spring Security. So how can we reduce that even further? While you could use authentication principal directly, it's recommended that you use it as a meta annotation. So you add that annotation to your own annotation. You create it and you call it whatever you want. I call it current user. You call it whatever you want. But that belongs in your code base. And so now what happens is Spring Security will resolve that for you automatically. But if you remove Spring Security, you just remove authentication principal once, and then create a new processor to process current user using whatever mechanism you needed that you swapped Spring Security out with. But of course, you would not do that because you wouldn't want to hurt my feelings. So you're going to keep Spring Security. But I do want you to know that this is certainly best practice. And so now we're able to access the current user. We have no Spring Security code in our controller. And if we need to access the user anywhere, we have just our code, our domain model, and we have access to all the attributes. So here I can find all the messages that are to the current user very easily. So hopefully you guys don't have Spring Security code all over. If you do, then you can use this to help clean it up. All right, so now we're going to talk about Spring Security, Spring Data integration. And I'm accessing the current user through Spring MVC. But there's other reasons that I want to be able to access the current user. So if you think about authorization, who here has used Spring Security for authorization before? All right. Who here has an application that has lots of domain objects and you have to page the objects? Hopefully everyone raises their hand. OK. Yeah, you have to page the results because you don't want to look up the whole database, right? So Spring Security domain level authorization in the past, you'd have to look it up and then do a check on it afterwards. That doesn't scale. And in fact, almost every authorization you find out there within the Java world in particular, you have to do this style, and then you'd have to query again, and it just doesn't work. So most people end up having to write queries that have their authorization logic built into it. So how do you do that? How can we make that easier? And so first of all, how can we do that, and how can we make that easier? Well, Spring Security has some integration with Spring Data. And all you have to do is create a bean that looks like this. And now you have Spring Expression language support within Spring Data. So who here has used Spring Expression language? Anyone? OK. It's pretty familiar if you've seen any other expression languages. But here you can see now I can customize my Spring Data query. And it's selecting messages from M where it's to the current user. So principal in this instance is our user domain object that we just talked about. And that works because our user details service is returning an instance of user and user details. So since it's an instance of user, user has an ID property, and we can access that property very readily. Now, you might say, well, what else can I do with that? Well, you can do more fancy things if you want. So for example, if you're an admin, give me all the results, or give me the results that are to the current user. So it's starting to get a little more interesting, but what benefits is this giving me? Well, it makes paging a lot easier. Spring Data, you could return a paged object, and it'll return the number of values that match, and it'll return the actual values. So that makes it easier, but I'm still having to keep track of what it means by security. So hopefully someone gets this joke at least. In the future, we plan on providing support for more advanced features with Spring Data. And so we aren't there yet, but this is kind of an idea of what we have in the future. And for those that don't get it, in the year 2000 is a Conan O'Brien gag that basically it means in the future. And it's really funny, so you should be laughing. But enable ACL security is kind of an idea of what we would do. So if you were the user that existed when you created a new message, then you would automatically have access to it. And then you could modify those permissions. And then if you found results using this repository, only users that had access to that would actually be returned. So it basically add your ACL security queries for you automatically, some of that being pluggable and also providing some default implementations for you. So this is what we hope to provide, and I think it will be coming in Spring Security 4.1. It is not there now, but this is kind of the direction we're going with things. All right, so we've talked a lot about this, and we talked about passwords in our domain model, but we now need to kind of talk about password storage. So right now, our passwords in our system are stored in plain text. And they're safe because they're in the database and there's a password to the database, right? Everyone should be laughing. I'm hilarious. No. But in all seriousness, the thing is you need to protect your passwords. And so how can you do that? Well, in the last milestone of Spring Security, we are going to provide some additional support for that. And the reason for it is the way you do password security has changed a lot over the years. You think about it, back in the day, that was enough to protect your passwords, is using a username password on your database. But it's evolved a lot. It used to be MD5. You hash your password at MD5 and everything's perfect. Then we found collisions in MD5 and we went to SHA-1. And SHA-1 was fabulous. And then we realized that we needed to do SHA-256. And then people started cracking things with GPUs and clouds. And we realized that SHA-256 is not all that great. And we needed one-way adaptive passwords. And we're using things like bcrypt now. And so the point here is that password storage has evolved a lot over time. And you're going to have a system that's existed before the best practices of today are there. So we're going to, in the next milestone of Spring Security 4, provide ways to help you upgrade your passwords storage mechanisms. And so that'll help you keep up to date with the newer mechanisms. And in order to do it right now, this is actually right now, if you want to do bcrypt, all you have to do is say, use the password encoder bcrypt. You're done. But the thing is, if you have an existing system and your password already exists, now your password's stored in one format, and you're basically trying to validate it in another. So we're going to try to add some mechanisms that will make it so you can seamlessly upgrade users' passwords to newer mechanisms. So that's enough on password storage, but again, no plain text in your database for passwords. Cross-site request forgery. Who here has heard of cross-site request forgery? Okay. Who here knows what it is in detail? In detail? Okay. Dave, I hope you were raising your hand. Dave's another Spring Security guy, Spring Security OAuth. Among just about everything else, he does everything here. Anyways, so we'll go over that in a little more detail. We're going to take a little demo here. So I need to double check that I have the proper config to exploit this, and I do. So cross-site request forgery is an attack that can happen in many different contexts. So make sure I'm still logged in. The main thing is that you have a user that's logged into a site, and they forget to log out. That's the fundamental premise of cross-site request forgery. And then they go to some other site. That site might be compromised because they had a cross-site scripting error and someone injected code onto their web page. That site might actually be an evil site that's just being malicious altogether. But the point is it could be trusted or it might not be trusted. And if it is trusted, it is probably hacked. But that actually happens quite a bit. So now we have this website. It's evil or hacked, and it has this win money button. Who here likes to win money? Yeah. So you're all going to click this button, right? I know I will. But before we click on it, we're going to actually look at the code a little bit. So the code is pretty simple. It's just a form, and it's doing a post to localhost, and it's going to with /100 after it, and it has a hidden input called _method delete. You can probably guess what it's going to try to do. It's going to try to delete the method or delete the message. And you might be saying, "Well, are you kidding me? I'm not going to click on that." Well, you don't have to click on it. It could be automated with JavaScript behind the scenes, submitting to a hidden iframe or something like that. And believe it or not, there are people that would click on that. So you have both problems in real life. So let's go ahead and click on it and see what happens. Sure enough, my message is removed successfully. And if I visit the original page, it did get removed. So we'll talk about why that happened, how it happened, and how we protect against it in just a moment. But now we're going to do a different demo. Oh, my CSS is not up to, or maybe I need to refresh the page. Yeah, sorry. We've seen this before. Everyone loves to win money. We've already gone over that, so everyone's going to click on it moving forward. But again, this isn't actually how it'd be laid out. It's just trying to find an easy way to demonstrate this for you. So this code actually looks a little different. We have a form, and it's submitting to an anchor tag. And the anchor tag, it's not going to do anything if I submit this form. And we have an input, and there's no hidden value, but we do have an iframe at the bottom. And so what does this page really look like? Well, I have some very fancy CSS. Not really fancy at all, but fancy enough. And you can see if I make it semi-transparent, you can see what's happening here. I have the iframe, and it's laid over this button. And in case it's hard to see in the back, I'm just going to make this a little easier to see by making it not transparent at all. Now you can see there's some delete buttons. So what is this right now? It's those delete buttons. I've zoomed in on those delete buttons in the iframe and laid it over the button. And so now if I make it totally invisible again, I'll hover over the win button just to kind of point some things out. You could clean up the CSS if you really wanted to make this more, but there's an arrow right now. But as I move over, there's the delete button. So if I click on it, it looks like nothing happened, right? It's because it's submitting in the iframe. So if I refresh this, I deleted it. Okay? Clickjacking attack. UI redressing, there's a number of names for it. So how do we protect against these attacks? Well, in Spring Security, we're in luck because the easiest way to do it, particularly with the Java config, is to not disable it because it's on by default. But the other thing is there is a little more to it. So let's go over the slides and see what's going on behind the scenes. So just real quick, anyone have a reminder for me when this session ends? Anyone real quick? Half hour? Thank you, Dave. So just trying to make sure we get everything covered here. So we have cross-site request forgery protection. And the request we saw beforehand was just underscore method delete. But what we've added to this now is underscore CSRF. So this is another parameter that's required in our post. And the reason why this is important is because no matter what domain we're submitting from, the cookie, the JSessionID cookie, is going to be submitted along with it. The domain can't read the cookie, but when it makes a request to that domain, it's submitting the cookie automatically. So what we can do is we can include this randomly generated token, and that token is unknown by the site that's been hacked or the site that's trying to exploit us. So it can include it, and the request will get rejected. So now this is a favorite question of mine, and some might say this is where I get up on my soapbox, but when do I use cross-site request forgery protection? My answer, security is never a clear-cut answer. There's lots of ifs, ands, or buts, but if I had to answer that generally, I'd say if your application is being used in a web browser, is it being interacted with through a web browser? And so people say, but my application uses JSON, so I don't have to worry about it. And my response is, well, take a look at this form. What do you think this is going to produce? It's going to produce a request that looks like this. It looks a lot like JSON. You know what? JSON is not going to protect you necessarily. So it's, JSON is not going to protect you, and then, inevitably, if they're using JSON, they're going to say, but my application is stateless. And I say, OK, well, that's fine. What are you doing? And someone might even say, I'm using basic auth, because it's pretty easy, gets me going. But that authorization header is included automatically by the browser as well, just like the JSessionID. Same problem. Stateless does not necessarily protect you either. And I use a custom header and ignore cookies. This is starting to get a little more complicated, but these are real-life responses that I've gotten. And you can be doing these things, but I just don't want you to believe that you're protected, because while if you're using a custom header, it's not going to be included automatically, the problem is that now what happens when you leave your website? So someone logs in, they leave the page, and then they come back. Well, if you're doing all this, they're not going to be logged in. But then their response is, well, I put it in a cookie, and then I read it from my JavaScript, and then I include it in the header and make a request. So I say, OK, well, you've just traded a cross-site scripting vulnerability, or cross-site request forgery vulnerability for cross-site scripting. So now people can read your session information from JavaScript, which is also bad. So in short, going back to my premises, if you're using a web application to in a web browser to access your APIs, you should use cross-site request forgery. And there are ifs, ands, or buts, but that's the quickest thing without knowing all the details of your application. So how do I use it? Well, we said it was configured on by default, but we also need to use proper HTTP verbs. And when I say proper, it's kind of loosely defined, because as long as you use like a post, put, or a delete for your HTTP method, Spring Security will require the token. But we don't require the token on gets. And the reason is we don't want to leak that information out to everyone else. Gets should not have private information. If you're doing a search and the search has a social security number, it should be a post. It's not very RESTful, I know. But read the HTTP spec, and it'll talk about securing your HTTP requests when you're doing sensitive information. Then we have to configure it, and we have to include the token. So how do we include the token? We could do it like this. There's a value on the HTTP servlet request attributes that's _CSRF, and we can include it like that. Spring Security provides a JSP tag that allows you to do it easily. Or if you're using Spring's JSP tag library, it's automatic. Or if you're using Timeleaf, it's automatic. Grail's tag library is also automatic. And your result would look something like this, pretty much what you would expect. So now we're going to do security response headers. We're going to kind of breeze through this one just a little bit. We did the clickjacking demo already. But the main thing here is that when we enable it, it basically spits out an extra header, xframe options deny. And xframe options deny is basically saying, if you try to render this content in a frame, reject it. So the browser's not even going to try to render that iframe. There's going to be nothing in there for me to click on. So they may overlay it and everything like that, but the delete button's no longer there to click on. And so this requires browser cooperation, yes. So you need a modern browser to help protect you. Some people try to use frame busting techniques in JavaScript. If you do some research out there, those are very hard to do right and next to impossible. And so it can help supplement this, but it's really not going to help you a lot. And there's other options too. You can do same origin, so maybe you want to frame it with your domain, then you can do that too, or you can specify which domains. There's some other headers on here too. Before I get into them though, we're gonna do a little choose your own adventure. Who here wants a lot more time for questions at the end? To clarify, I can still ask questions after the talk, but it won't be like while I'm on the podium. So who here wants questions after the talk while I'm on the podium? Who here wants to go a little longer talking versus asking questions up here? So go a little longer talking. A little longer talking? All right, I think we have it. We won't even bother asking the other question. So we'll go a little more depth here, but I did want to get all our responses out. So we're going to just go till 2 o'clock talking, and you can ask questions afterwards. So who here knows what content type options no sniff is? Anyone? What that is for? All right, so content sniffing is basically a way of trying to predict what the output of your response is and how it should be encoded and interpreted. And so what you can do is you can actually create objects that are files, formats that are valid in multiple formats. So you might have an image, it's called a polyglot, and it's valid in image and valid JavaScript. So I upload it to your server, and all of a sudden I have a valid JavaScript file on your server. So how do I exploit this? Well, certain browsers that shall remain nameless, Internet Explorer, oh, did I say it? Have a history of interpreting that content based upon what the request looks like. So they try to guess. And it might guess wrong, because the way that you encode it and the way that you interpret it and the way that you're validating it, all of these things are important based upon the content type and how the browser sees it. And so the browser might actually interpret that as JavaScript, and then you have cross-site scripting bug when someone uploaded an image. Now, you should scrub the image when you get it uploaded in files and stuff like that, but these are additional steps. So we say no sniff means don't look at the body of the response. Instead, I want you to only respect the headers that I'm sending back. Another one, cross-site scripting protection. Who here's familiar with that header? Everyone knows cross-site scripting, I assume? Yeah, so a lot of hands there, but okay, so browsers have some built-in cross-site scripting protection. And when I say some, I mean you're not protected. Don't assume that's going to help you. It's just kind of a backup is the way I'd view it. So it's for a reflected type attack. A reflected attack is when, say you have a search, and I type in the search hello, and then it says your search for hello are displayed below. It's kind of echoing out what I typed in. And so the key is the request has what is displayed on the page. So the browser can say, okay, well, if that looks like JavaScript and then it's trying to execute some JavaScript, the content you just typed in is trying to be JavaScript, I'm going to block it or do something with it to prevent it from being an exploit. So it helps you. Now, certain browsers that shall remain nameless, Internet Explorer, again, someone keeps saying something, I don't know, but have a history of actually trying to protect you, but actually causing an exploit that wouldn't otherwise happen. So your website is totally secure, and someone tries to do a reflected attack, and it tries to block it, or tries to prevent the attack from happening. Well, there's a number of ways to prevent the attack from happening. One way is to try to adjust the way that it's rendered out. And, so it might, instead of you said script alert hello, it might like try to escape the script, but it might do that incorrectly, and that actually caused the cross-site scripting bug. So another way of doing it is blocking that content from rendering at all. And that's what this is telling it to do. Don't try to fix it, just don't do anything, because I don't trust you. And so this is these bugs have been fixed, but they're good practice to continue doing, because in security, things always kind of come full cycle. So you always want to make sure you take those into account. So these are done, again, by default by Spring Security. Cache control, pretty obvious. Log in, log out, someone hits the back button. You don't want anyone to see your content. Spring Security will automatically inject cache control. Now, I know everyone's like, whoa, we got browser performance here. I can't not cache anything. If you explicitly add a cache control header yourself, Spring Security backs out of the way. So your images, CSS, JavaScript, Spring MVC will add reasonable caches to those, and Spring Security backs out of the way, and they're still cached. This is just the default. If you forgot to add a cache control, you're not thinking about it, it will prevent it from being cached. We already talked about X-frame options. Those other things are various ways of preventing caching, the cache control pragma and expires. And then strict transport security. Who here has heard of that? Anyone? I figured Dave, if he was paying attention, would raise his hand. But strict transport security is basically a way of helping prevent man-in-the-middle attacks. So everyone know what a man-in-the-middle attack is? A lot of head nods. Just real quick, you go into Starbucks, someone sets up their own Wi-Fi, you think you're connecting to Starbucks. You actually connect to their own broadcast, and now they can see all your traffic and manipulate it and intercept it and do that sort of stuff. So you go into the Starbucks and you type in mybank.com. And when you type in mybank.com, what happens? Well, HTTP, it goes over HTTP. My bank is probably going to do a redirect to HTTPS. But the problem is you've already made the mistake of doing HTTP. So the man in the middle can already intercept it. Maybe he redirects to mybanks.com or something like that. He alters it slightly. And he does a redirect to it, and it's over HTTPS. So you're like, oh, yeah, I didn't know it. You might not notice that it's a new domain, just slightly different. You type in your username and password, you're owned. All right. So how do you help prevent against that? Well, strict transport security is a header you can send from now on for this domain, always request HTTPS. Don't even if they do HTTP, send them immediately to HTTPS. And this header is only sent back in a HTTPS request. So the reason for that is because you don't want a man in the middle to inject this header on a site that doesn't have HTTPS, because that'd be a denial of service attack. And the age here is a year, if I remember correctly, and it includes subdomains. You can configure that slightly if you want. But the thing is to remember is that's on by default, and it'll only happen over HTTPS connections. And the other thing is the browser will only honor it if it trusts the CA that signed the certificate. So if you're testing it and you want to see if it works, make sure if you're doing a self-generated certificate that you trust the CA, because otherwise it's not going to do it. And there are some people that are on this magic whitelist. I call it a magic whitelist. It's basically included in the browser where this is on by default immediately. But a lot of us aren't that fortunate, so you have one chance for the man in the middle to happen, but then hopefully your header will help ensure that they go immediately to HTTPS. So it really reduces the attack surface. All right, so we're going to go through testing support here fairly quickly. Testing support is also new in Spring Security 4.0. This is what you used to have to do to get testing support for method level security. And if you wanted, you could customize it. So you customize the user details, and you might want to do your own custom user. But now, if you want to do it, you add with mock user. And what is that going to do? It's going to populate with a user named user, role of role user, and you will automatically be authenticated as that user for each of the test methods. You can move that to individual methods if you wanted. So you could have some tests that are authenticated, some that are not. And you can customize attributes on it. So maybe you want an admin user that has a role admin. Again, you'll notice roles, it has an implicit role underscore. You don't have to do that. But it's still under the covers using role underscore, because there are different types of authorities that can be used. So we have that. We can also do with user details. So the issue that we have with this is our Spring Data layer is assuming there's an ID on our current user. This is a mock user. The mock user that Spring Security knows about has no property ID on it. So what we can do is we can say with user details. And what that does is it uses our user details, looks up a user by rob@example.com, and it uses our custom object for us. Now, the problem with this is it still must exist in our database, and every time we're doing a database hit to look that up or invoking our user detail service. So we might want to not rely on that. So we can create our own annotation and say with security context, this is Spring Security's annotation, and then add a factory to it. And then we create our own annotation. And so you can see these properties correlate to my user representation, right? And now all I do is I create an implementation of this interface, and it basically uses that annotation to create my user. And you could even have like different notions of a user. So instead of saying with custom user, you might say with Rob. And that might be one of the people in your stories. If you're doing agile development, you might have different personas of people interacting with the system. So you'd have with Rob, and it'd actually have all the values filled out for you automatically. And then you'd have with John as another one, or Susie, or whatever. So you can actually, and that way you don't even have to fill out the attributes. But here it's going to use Rob as the custom user, and you can customize it to use Luke by modifying the attributes, or as I said, you could use that other strategy. So what about Spring Test MVC? Has anyone used Spring Test MVC? Number of hands. So in the past, you had to apply the filter separately, and then there was no way to authenticate as a current user, as a user when making the request. So now we can just say apply Spring Security. That takes care of your adding your Spring Security filter chain to that mock MVC builders, and it adds some special support so that when we use those annotations, the requests are made on our behalf. So we can now do our mock MVC test with the same annotations that we just saw. There's also support for, we talked about cross-site request forgery. How do we know this secure randomly generated ID? How can we test creating a new message? Well, we can just say with cross-site request forgery. Spring Security will add a valid cross-site request forgery token to your mocked request, and it'll perform successfully. All right, so now we're getting to WebSocket security. So WebSocket security. Who here has done WebSockets in Spring? Who here has secured an application with WebSockets in Spring? Okay, I'm glad there's a few hands up because otherwise you're probably mistaken. In the past, you could authenticate with Spring WebSocket, but there's no real way to do authorization. And we don't really actually have time to do the exploit here, but we'll talk about how this works. So typically, when you send an instant message, you send it to a endpoint of app.im, and that go into our application. And right at that point, I would make sure that the current user that's logged in is marked as who's sending that message. So you'd override that, and then you'd send it out to the user that it's actually to. And so that would happen in message mapping/im. That's just your controller. And then it's going to end up going to queue/messages-user ID. Well, and then it comes back to the client browser. So what you could do is instead of sending to /appim on the client side, you could actually just say queue/messages-user and guess the identifier. And you might say, well, how do I guess the identifier? Well, you could just do a brute force and just do it to a whole bunch. In this instance, you might say, hey, Luke, give Rob a raise. And you would change the from to boss. So now Luke thinks that Rob's supposed to get a raise, and Rob gets that raise even though it wasn't from that user. If you're doing like a trading system, you could just intercept send a whole bunch of messages to route all the transactions to send money to your account. So you wouldn't even have to know which user or account it is. You basically just broadcast like, give me all the money. I don't care who it is. So how do you protect against that? Well, we have an extension point to Spring's messaging support. And Spring's messaging support has support for WebSockets. And this requires Spring 4.1, by the way. It had to add some new hooks to get some of the stuff to work well with Spring Security. And then we can configure it. And it looks kind of similar to what we saw earlier in the HTTP. Now, what we're doing is we're saying, so matchers is just an interface. Matcher says, I'll take any message matcher. Message is just something that you'd receive. And it's basically a single method. It says, if it matches, return true. If it doesn't match, return false. Pretty self-explanatory. So here I have a static method that is actually necessary in the current version, but we're going to add some better things like any message, similar to any message, that allows you to match based upon the type. So messages that are coming in inbound to topic and queue, they should be rejected because that should only be happening in our outbound channel. So when I say outbound channel, back to this diagram, inbound is coming from the browser. Outbound is going back to the client, right? So we don't want anyone on the client side, the browser, sending messages directly to another client. It has to come through our brokers, right? And so this is just basically saying no one should be able to do that. And then we actually disable security for the outbound channel because in all practicality with this config, the only person that's sending messages to the outbound is our application, so we can trust that. There may be cases where you might need to make adjustments to that, but that's up to your application to determine. So that actually leaves us with still a little bit more. We have WebSocket security, and so who has anyone? I guess we already talked about who's used it, but one of the things with the JSR is that if you authenticate as a user, and then you create a WebSocket connection, and then that HTTP session, say you had a HTTP session for that user, that HTTP session expires. One of the things that is defined in the specification is that WebSocket connection should be closed. So if you have a web application, you log in, and you start chatting, and you keep chatting, all that. If your HTTP session dies, then your WebSocket dies. And the other thing is, there's nothing in the spec that says that the WebSocket connection keeps the HTTP session alive. So you can see why this is a problem. I'm chatting. HTTP session expires, forces me off my WebSocket connection. I'm disconnected. So it's actually a pretty bad thing. So what can we do to fix that? Well, we have a new project called Spring Session. And Spring Session, basically similar to how we replaced the HTTP servlet request, so we could return our custom users and stuff like that from the HTTP servlet request. We can also return a custom HTTP session object, because the HTTP session is just an interface, right? And that interface can now be backed by whatever store we want. So this has a lot of advantages. You could do something like clustering in a transparent fashion. Plug it into Redis, right? Put it into Redis or your favorite NoSQL data store. The other thing is right now, the container is limited to using JSessionID cookies to determine the session ID. What if you're doing a REST service and you want to have a header be the ID, and you don't want it to have JSessionID because that basically ties you to Java for your spec? You could put it in an arbitrary session ID or header ID. Maybe it's an OAuth token. The OAuth token is actually extracted out, and that's just an identifier for your session. It also allows, like say you went to the library, forgot to log out, or you weren't sure you forgot to log out, and then you go back to your computer and you're like, oh, I forgot to log out. Someone might be looking at my email account. You could go in and view all the active sessions, because we could query them from the database, and then invalidate it. But what's more is in WebSockets, every time we receive a message, we can actually just say, hey, looks like they made a request. We'll go ahead and keep that session alive. So now our HTTP session is no longer expiring. So there's lots of practical uses for Spring Session. And it's already been released in milestone form, but it will be coming in GA version to provide basically the session replication and WebSocket support. But we have lots of other ideas of what we can do with Spring Session as well. And I really hope you guys enjoyed the talk. I hope you guys found it worthwhile to hear the rest of my ramblings rather than making things a little more concise and getting questions in. If you want, the source code is on GitHub Spring Security 0 to 4.0. And in all honesty, I can't remember if I pushed it yet. So it might not be there right now, but it will be after the session. If you need more resources on Spring Security, there's a Spring.io URL, -Spring Security. And you can find me on Twitter at Rob_Winch. One more quick plug is if you're wanting to learn more about securing stuff here at Spring One, Dave Sire over here is the Spring Security OAuth lead, and much smarter than myself as well. So if you want to learn a lot more, go to Security for Microservices with Spring and OAuth 2 at 4:30 today. Thank you again. If you guys have any questions, feel free to come ping me. But once again, thank you again.